In the previous two lectures, we talked about multi-criterion decision-making and then spatial decision-making. Where we want to go next is decision-making under uncertainty, where there's some probabilities involved. So to do that, first we want to take a little time out and talk for a moment about probability. Now, if you've already taken a class on probability or if you know a lot of probability, you can skip this little unit. If you haven't, this will give you enough understanding that you can, you'll know what you need to know to do what we're going to do with respects to decision-making under uncertainty. So probabilities are just the odds that something happens. And so when you write down probabilities, they have to satisfy three axioms. First axiom is that any probability is between 0 and 1. So if something can happen, it's probability 0. If something's definitely going to happen, it's probability 1. Now, even if you're totally sure something's going to happen, the probability can't be bigger than 1. So you can't say, I think there's a 110% chance this is going to happen. No, it's got to be between 0% and 100%. Second axiom is a little more complicated. We have to make a distinction between outcomes and events. So an outcome is just any individual thing that can happen. An event is a subset of outcomes. So if I write down all possible outcomes, then the sum of those probabilities has to equal 1. So if I think about flipping a coin, right, there's two outcomes, heads or tails. The probability of heads is a half, the probability of tails is a half, and when I sum those two things together, I get 1. That's the second axiom. Easy. Third axiom. If I have an event, now an event would be a set of outcomes, and the event A is contained in the event B, then the probability of A is less than the probability of B. So one event might be that I get a heads. We write these as little sets. Another event might be that I get a head or a tails. Well, the probability of getting a head is a half. The probability of getting a head or a tails is 1. And since getting a head is a subset, right, of getting a head or a tails, the probability of a head 1/2 is less than the probability of getting a head or a tails, which is 1. That's the third axiom. So that's it. Those are the three things. Probability of any outcome or event is between 0 and 1. Could be 0, could be 1, but it's somewhere in that range. That if I add up the probabilities of all the different outcomes, those sum up to 1. And then if I have one event that's a subset of another event, this is this axiom, then that first event has a smaller probability than the second event. So that's the axioms. Now there's actually three different types of probabilities. First type of probability are classical probabilities. So these are the sort of things that mathematicians play with when we think about things like dice and roulette wheels and things like that. So for example, if I roll a die, I can sort of logically or classically assume that the probability of getting a 4 would be just 1/6. And the probability of getting an even number would be 1/2, and the probability of getting an odd number would be 1/2. So this is classical probability, where you can sort of write down mathematically in some pure sense what each probability would be. Now there's a second type of probability, which is frequency. So here, like with a die, we know that it's going to be a 6 because the die is sort of equally shaped. But there may be other things where we don't know, but what we can do is we can count. We can sort of do a frequency count. So we've got lots of data, and we can look at all that data, and from that data, we can make an estimate of what we think the probability is. So for example, suppose I ask you the following question. Do more words begin with R, or do more words have R as their third letter? Right? So this is the question. Now what you could do is you could just guess, right? You could think, well, I'm guessing that 2% of words have R as their third letter and 8% of words begin with R. Another thing you could do is you could open up the dictionary and you could count, right? So you could just, first of all, you could just sort of look at how many pages are there that seem to begin with R, and you could maybe get that, 6% or something begin with R. And then you could randomly flip through the dictionary looking at words and see what percentage of words have R as their third letter, and you might find that that may be like 11% or something. And you might find out, oh my goodness, that this is actually bigger. Well, what you're doing is you're sort of estimating through frequency what the probability of having R as its third letter is, and estimating through frequency what the probability of having R as its first letter is. So frequency just means you count things, right? And then you figure out the probability from there. So it's not a pure probability like rolling a die that it's 1/6, but it's just how often it seems to happen. So if you look at something like, is it going to rain next July 7th, or June 7th, I'm sorry, what you can do is you could go back and look over the last 100 years, and you could say, I've got 100 years of data, and on 26 of those days, it's rained, and on 74 of those days, it hasn't rained. And so then you could say, I think the probability of rain is 26%. Now again, this isn't like rolling a die. This is just counting it up, right? And this is a frequency estimate of what the probability is. When you make these frequency estimates, you're making some strong assumptions, one of which is that what we call stationarity, that nothing has changed over the last 100 years, that the probability of rain has been stationary, it hasn't changed, and so this is a good predictor. So ideally, right, we know classically the probability of something. And if we don't know classically, then the next best thing would be to use all that data we've got out there in the world and do a frequentist account. Sometimes we can't do either one of those things, and we're stuck with subjective probabilities. So these are cases where we kind of have to guess, or have to, and we'll talk about this actually, what we'd want to do is use a model, right? We want to have some sort of model we could use to figure out what a subjective probability is. So for example, here's a case that is sometimes given by psychologists. So Shelley majored in political science and was very involved in college Republicans. Write down probabilities for the following events. So I've got, let's think. Now, so now I sit and I think Shelley's a political scientist, right? That's sort of interesting. She's a Republican, so that means maybe a conservative political scientist. You know, maybe she's, you know, more interested in money. What are the probabilities she'd do these things? Well, flight attendant, I might think, well, boy, that's not very likely, right? 5%. Blogger, I could think, you know, maybe blogging, maybe there's a 10% chance she blogs because, you know, she was a political science major and she was a Republican, so maybe she likes to blog. Flight attending while finishing her MBA, well, that seems actually pretty reasonable. Let's give that a 10% chance. And then medical field, let's say, you know, medical, a lot of people in the medical field, so let's just put a 15% chance she's working in the medical field because that's about what, you know, the base rate for what people work in the medical field. So these would be my probability estimates, just subjectively writing those things down. Well, let's look at these a little more carefully. I did something wrong. What did I do wrong? Remember our three axioms. What were our three axioms? Axiom 1 was, right, that the probabilities had to be between 0 and 1, right? Axiom 2 was that all probabilities summed up to 1, so the sum was 1. And the third one had to do if event A was contained in event B. So let's go back and look at what I did. What did I do? I assumed event A, that she was a flight attendant, that this was only true 5% of the time. And event C, I had the probability that she was a flight attendant while finishing her MBA, was 10%. Well, this can't be, right? Because if she's a flight attendant, right, that's this event, event A, right, contains event C. So if she's a flight attendant while finishing her MBA, then she's also a flight attendant. So this number, right, this 10%, has to be smaller than the 5%. So I made a mistake. In fact, this example, the one I gave, remember I said psychologists like to use this. This is an example where we see a bias, where people make mistakes. And in the later lecture, we'll talk about these sort of biases. So subjective probabilities are dangerous because when we just start writing down numbers, right, we may not satisfy those axioms, and so then our probabilities don't make any sense. So suppose somebody asks a question like, will housing prices go up next year? How do you do it? Well, one thing you could do is you could just guess. You could say, well, I think there's a 30% chance housing prices go up next year. What we want to do in this course, right, is think about, well, why would you think that, right? Maybe we should write down a model. Maybe we should think about what are all the things that could go into affecting housing prices, and then based on those things, think about which direction the economy is moving, and then from there, make some sort of assessment of what prices are going to go up. So when we think about cases where we don't have a classical probability, right, when you pick up a probability textbook, they'll say, really, there's two things you can do. One is you can do a frequency method, and the other is you can use subjective method. We're actually going to argue for a third way, which is even though these probabilities are subjective, we want to think of these as sort of model-based probabilities. What we're going to do is try and construct a model, and based on that model, figure out what we think the probability of an event will be. Here we have probability in a nutshell, right? There's three axioms. The probabilities are between 0 and 1. Probability if you add up all the possible outcomes, that is the sum to 1. And if one event contains another event, it's got to be more likely. That's all. That's it. Those three axioms. And again, there's three types of probability. One is classical, where we know sort of mathematically why a probability is what it is. Second is frequency-based, where we've got all sorts of data, and based on that data, then we know, we have some good estimate of what we think the probability is. Third case is what's often called subjective, is where we don't have data, and we don't have a classical reason, and so we sort of got to guess. Well, rather than guess, what we can do is we can try and construct models and use the model to give us some, estimate of what we think the probability is going to be. And so these probabilities then are going to come into play in the next lecture when we think about how do we make choices when we don't know something for sure, when we know there's some probability of it raining or some probability of prices going up. So that's where we're moving next. Decision making where we've got uncertainty in these probabilities. Thank you.